Hey everyone, and welcome. I am absolutely thrilled you could join me for today's explainer, which is brought to you by Forge College. So, today we're diving into a really crucial piece of our Solidity from Zero track. The lesson is called Designing Event Schemas for Logging and Monitoring. If you've been following along, you know this fits right into our capstone on comprehensive event-driven contracts. We're going to take all that abstract theory we covered previously and turn it into a concrete, beautifully organized filing system for your smart contracts. And trust me, your future self, and definitely your highly caffeinated front-end developers, will absolutely thank you for this.
All right, let's take a quick look at our architectural master plan for today. We'll start by defining the black box problem, then look at the building blocks of events, tackle indexed versus non-indexed fields, design some gas-conscious payloads, see emitting in action, and finish up with a rigorous schema validation. It's a packed agenda, so let's just jump right in.
Starting off with Section 1, the black box problem. Why exactly do we need a blueprint in the first place?
Building on our previous lesson about contract scope, we've got to face a pretty stark reality here. Querying a contract without a proper event schema, it's basically a total nightmare. Imagine a pitch-black, windowless warehouse filled to the ceiling with billions of unmarked cardboard boxes. Now go find a single receipt from, say, last Tuesday. Good luck, right? Well, that is exactly what your front-end app is doing, just fumbling around in the dark on the blockchain. We absolutely need a highly logical, predictable system to announce state changes to the outside world. Otherwise, your indexers and monitoring systems are, well, completely lost.
Moving on to Section 2, the building blocks of events, or how we actually draft this filing system. Let's actually pin down what an event schema is. Simply put, it's a concise set of rules and declarations that dictate exactly how a smart contract logs state transitions and transaction context to external systems. Think of your event schema as the official API blueprint for your off-chain systems. You know, when you build a traditional web app, you spend a ton of time designing your API endpoints so they're predictable, right? Well, events serve that exact same function in Solidity. They are literally your contract's megaphone to the outside world, keeping your logs predictable, specific, and, most importantly, incredibly minimal.
Now, to draft this API correctly, we've got some golden rules we need to follow. First up, always start your event names with a capital letter. Think deposit or withdrawal. Second, use highly specific action words. Please, don't just call an event update or stuff happened. That helps no one. Call it fee changed or ownership transferred. Third, you always want to include the transaction actor's address. If a state changes, we really need to know who triggered it. And finally, keep those payloads minimal. The blockchain is a wildly expensive place to store your personal diary, so leave the heavy data off-chain and only emit the essential IDs and state snapshots that are actually needed to reconstruct what happened.
All right, Section 3, indexed versus non-indexed fields. This is all about filterability versus gas costs. This brings us to what I like to call the chief engineer's core dilemma. We have to balance how easily a backend can search for an event against how much it actually costs to emit. On one hand, you have indexed fields. You can think of these like paying extra postage for VIP tracking numbers on a package. They become highly searchable filter keys for your app. But here's the catch. You are only allowed a maximum of 3 of these VIP slots per event, and they definitely cost more gas. On the other hand, non-indexed fields are kind of like heavy luggage stuffed cheaply down in the cargo hold. This data is stored in the log data section. It's way cheaper on gas, but it is completely unsearchable by your backend. So you really have to choose wisely what gets the VIP treatment and what rides in cargo.
Which leads us perfectly into Section 4, gas-conscious payloads, looking specifically at the deposit event blueprints.
Let's see how this VIP priority map plays out in the real world. In a standard deposit event, we typically have 3 fields: account, amount, and balance after. Notice how only the account field is indexed. Why is that? Well, monitoring systems frequently filter by a specific user, so it's our primary search key. The amount and balance after fields, though? Those are massive numeric values used for analytics or state reconstruction. They are incredibly useful, sure, but they make terrible filter keys. Honestly, indexing them would turn your contract into a super expensive, gas-guzzling monster. By keeping them non-indexed, we provide all the necessary data cheaply, right there in the cargo hold.
Okay, Section 5, emitting events in action. Let's bring this blueprint to life.
Let's look at the actual mechanics and see how we build a rock-solid workflow in code. Step 1, declare the event right at the top of your contract using specific types. Step 2, actually perform the storage mutation. Update your contract state. Step 3,
emit the event, passing in those freshly updated values. And finally, step 4, run a static compile to verify the ABI and ensure your parameters perfectly match up. Listen, the order of operations here is absolutely critical. If you mess up this order, your off-chain consumers will not be able to reconstruct the exact state of the contract at the time of the transaction.
And that brings me to the absolute golden rule here. Emit immediately after the storage write. I really cannot stress this enough. Always perform your state updates first and emit the event second. You want to capture the newly computed post state so that external listeners don't have to guess or manually calculate what just happened. If a user deposits 10 tokens, update their balance to 10 first, and then emit the event showing that their new balance is 10. It sounds so simple, right? But getting this backwards is actually one of the most common causes of front-end bugs in Web3.
Almost done. Section 6, validating your event schema. Time for our final quality assurance check.
Before we wrap up, visually validating this checklist ensures your artifact is perfectly formed. First, ask yourself about coverage. Does your schema match all critical state mutations? Like, have you accounted for every major action? Second, check your indexed fields. Do you have at least one filter key, like an address, but no more than 3? Third, do a gas awareness check. Have you stripped out large, redundant data blobs? Are you using minimal IDs instead of passing entire structs? And finally, the compile check. Does your compiler output a clean, warning-free ABI? Running through this simple list prevents scattered, inconsistent logs and honestly saves you from some really costly code refactors down the line.
So I want to leave you with this final, somewhat provocative question to think about. Are your smart contract events acting like precise, carefully engineered API endpoints, or are they just a messy, expensive diary of everything that happened? Designing a proper schema really is the line separating amateur code from professional-grade Web3 engineering. As you prepare for our next lesson, where we'll actually wire these emits directly into your function bodies, I highly encourage you to visit forge.college. There, you can master even more Web3 engineering concepts. Because, as we've seen today, a well-designed schema truly changes everything. Thank you so much for joining me on this explainer brought to you by Forge College. Keep learning, keep building, and I'll see you in the next one.